Welcome to my channel. So in this video I am going to discuss how to write the laboratory manual to determine the transmission and hybrid parameters of two-port network. So if students want to note down this manual in their notes or observation notes, so they have to follow some rules. So in general, how to write the observation for any electrical laboratory I have mentioned in the next slide. So on the right hand side page in the observation, first of all they must write the title, date and experiment number. After that they have to write the aim, apparatus required, theory, procedure, formulae, calculations, theoretical proof, practical proof, precautions and results. Okay, on the right side pages. Okay, so all these may not be able to, the student may not be able to accommodate all this in one page. It will take several pages to write all these things, to write the content of all this. Okay, so they must write only on the right side pages. On the left side pages they must draw the circuit diagram, they must draw the observation tables, and if model graph is there they must draw the model graph on left side. So these rules they have to follow. So these terms should be only on the left side pages in your observation or record, and all these must be only on the right side pages in your record or observation. So let us see how to write the manual for determination of transmission and hybrid parameters. So this is the title for this segment: determination of transmission and hybrid parameters of a two-port network. So you can pause the video to note down these values. I'm sorry, to note down the title in your notes. So determination of transmission and hybrid parameters of two-port network. So transmission parameters, you can even call them as ABCD parameters. Okay, so to determine ABCD parameters and hybrid parameters of a two-port network is the title. So let us see the aim. So here aim has been divided into two parts. So since here this manual has been prepared to do the hardware experiment as well as to do the MATLAB software experiment. So I have divided the aim into two parts. To determine transmission and hybrid parameters of two-port network using hardware is the first part. To determine transmission and hybrid parameters of a two-port network using MATLAB software is the second part. So you can pause the video and note down the aim in your observation. Or in your record. Next, apparatus required. So the apparatus that are required to do the hardware experiment, you must write down the apparatus in a tabular column. So in the tabular column you must write down the serial number, name of the equipment, range, type and quantity. Name of the equipment, range, type and quantity. So the apparatus required are regulator, power supply, circuit board, ammeter, voltmeter and connecting wires. So regulator power supply of range 0 to 30 volts 1 ampere. We need one regulator power supply. And we need one circuit board to do this experiment. And we need an ammeter of range 0 to 50 milliamperes, type moving coil type, that is MC. We need actually we may require more than one ammeter. Here I have mentioned only one. Depending on your circuit, you can write more number of ammeters here. Okay, so depending on in your circuit, in your practical circuit diagram, number of ammeters will be mentioned. So you just count those ammeters and you can mention that count here, or else you can write down as it is, which I am showing you here. So voltmeter of range 0 to 30 volts is required, and type is moving coil type. Moving coil means MC, and quantity required I have written only one. Depending on your circuit, you may require more than one voltmeter. And connecting wires as per requirement, we can't specify the number, so some n number of connecting wires are required depending on the circuit that we are going to design. Okay, so you can write required number of connecting wires. You pause the video and you can note down this tabular column in your notes. So for software experiment, the software required is MATLAB software. So we don't require any apparatus here, only MATLAB software is required to do the software experiment. So this is the circuit diagram. So here we are going to do the experiment on T network. So these are it's a 2-port network. So you can see 1 1 dash, port 1 1 dash. This is our port 1 1 1 dash, and port 2 2 2 dash. Okay, so T network has 3 elements here: R1 820 ohms, R3 2000 ohms, R2 510 ohms. So you can pause the video and note down this circuit in your notes or observation. Now let us see the practical circuit diagrams for doing the hardware experiment to determine ABCD parameters. So to determine ABCD parameters, first of all, open circuiting 2 2 dash, that is port 2 2 dash is open circuited. As I have already told you, ABCD parameters means transmission parameters. Okay, transmission parameters are also known as ABCD parameters. So first of all, to determine the ABCD parameters, we are open circuiting port 2. So since port 2 is open circuited, therefore port 2 is open circuited, therefore no current will flow through 2000 ohms. Okay, so even though resistance is there, no current will flow through it. So across port 1 we have connected a regulated power supply whose range is 0 to 30 volts 1 ampere, RPS 1, and across it we have connected an voltmeter. Okay, so voltmeter range is 0 to 30 volts, MC type. And in series to 820 ohms we have connected an ammeter whose range is 0 to 50 milliamperes, and type is moving coil type. Across 510 ohms we have connected an voltmeter whose range is 0 to 30 volts, moving coil type. So you can pause the video and copy down the circuit in your observation or notes or record. So this is one circuit to determine ABCD parameters. There is one more circuit to determine the ABCD parameters. that is this one, short circuiting to 2 dash, that is V2 equal to 0. Here V2 equal to 0. So say V2 equal to 0. So V1, we have connected a voltage source across port 1 dash. So whose range is 0 to 30 volts 1 ampere. So that is our regulated power supply 1, and across it we have connected an voltmeter of 0 to 30 volts. Type is moving coil type. And we have connected an ammeter in series to 820 ohms. In series to 820 ohms, we have connected an ammeter whose range is 0 to 50 milliamperes, moving coil type. And in series to 2000 ohms, we have connected one more ammeter whose range is 0 to 50 milliamperes, moving coil type. You can pause the video to note down this in your notes. Now, so let us see the circuits that are required to determine H parameters. So short circuiting to 2 dash, that is V2 equal to 0. Same circuit which we have seen just now. Same circuit. It is used here also to determine the H parameters. So V2 equal to 0. So port 2 dash is short circuited, and voltage source is connected. DC voltage source is connected across port 1 dash, whose range is 0 to 30 volts 1 ampere, regulated power supply 1. We have given some notation V1 to it. And a voltmeter of 0 to 30 volts moving coil type is connected across the source. And in series to 820 ohms resistor, an ammeter is connected 0 to 50 milliampere moving coil type. And in series to 2000 ohms resistor, and again an ammeter is connected of 0 to 50 milliamperes moving coil type. Okay. Now one more circuit to determine the H parameters, that is hybrid parameters. Open circuiting 1 dash. Open circuiting 1 dash, that is I1 equal to 0, that is current flowing, open port 1 dash is open circuited, therefore no current will flow through 820 ohms. So we have connected a voltage source across port 2 dash, whose range is 0 to 30 volts 1 ampere, that is our regulated power supply 2. And a voltage measuring element, that is voltmeter, is connected across the port 2, whose range is 0 to 30 volts, and type is moving coil type. And an ammeter of range 0 to 50 milliamperes moving coil type is connected in series to 2000 ohms. And a voltmeter of range 0 to 30 volts moving coil type is connected across 510 ohms. You can pause the video to copy down the circuit in your notes. So for doing the software experiment, similar to hardware experiment, here also you will design the same circuits. So open to determine ABCD parameters, open circuit 2 dash, that is IT equal to 0. So you can see R3, that is 2000 ohms resistor, it is open circuited, no element is connected across it, it is open, no current will flow through this R3. So we will take a DC voltage source and we will set a value of 30 volts in this, and across it we have connected an voltage measuring element, that is voltage measurement. And whatever voltage is measured by this voltage measurement element, it is displayed in this display. And in series to 820 ohms, a current measurement is connected. This current measurement will measure the current in 820 ohms and it will display that value in this display. And one more voltage measurement is connected across R2, that is 510 ohms, and a display is connected to this voltage measurement. So whatever voltage that is measured by this voltage measurement across this resistor, that will be displayed in this display. Now one more circuit, short circuiting 2 dash, that is VT equal to 0. So 2 dash is short circuited. Here 2 dash is short circuited. So here we are drawing the same circuits similar to your hardware. Okay. So the here DC voltage source is connected across port 1 dash, and a voltage of 30 volts is set in this DC voltage source, and a voltage measurement is connected in across this source, and a display is connected to this voltage measurement. This display will show this 30 volts here, and current measurement is connected in series to 820 ohms, and a display is connected to current measurement. So whatever current that is flowing through 820 ohms will be displayed here in this display. And in series to 2000 ohms, current measurement is connected, and whatever current flowing through 2000 ohms will be measured by this current measurement, and it will be shown in this display. You can pause the video and copy down this circuit in your observation. And for each and every circuit, if you observe, you have to copy down this power guy also. Pause the video and copy down this circuit. Okay, to determine H parameters using MATLAB software. So short circuiting 2 dash, that is V2 equal to 0. So you can see here 2 dash is short circuited. So 2 dash is short circuited. DC voltage source is connected across port 1 dash, and a voltage of 30 volts is set in this DC voltage source in the and across it a voltage measurement is connected, and to this voltage measurement a display is connected. So whatever voltage that is set in this regulated here DC voltage source, that voltage will be measured by this voltage measurement and will be displayed in this display. And an ammeter is not ammeter, current measurement is connected in series to 820 ohms, and whatever current flowing through 820 ohms will be measured by the current measurement, and it will be displayed in this display. And a current measurement is connected in series to this 2000 ohms, and whatever current that is flowing through this 2000 ohms resistor, that current will be displayed here in this display. And you even require a power guide for each and every circuit that is designed using MATLAB software. You can pause the video and copy down the circuit. One more circuit to determine the H parameters, that is hybrid parameters, is open circuiting 1 dash, that is I1 equal to 0. So 1 dash is open circuited. So in this 820 ohms resistor, no current will flow. It is open here. So we have connected a DC voltage source across to 2 dash port, and the voltage that is given to the here is 30 volts is set in this DC voltage source. That 30 volts is measured by this voltage measurement and is displayed in this display unit. Similarly, a current measurement is connected in series to 2000 ohms and a display is connected to current measurement. Whatever current is measured by this current measurement, which is flowing through this 2000 ohms resistor, will be shown in this display. And across this 510 ohms resistor, a voltage measurement is connected. This voltage measurement is further connected to display. So this voltage measurement will measure the voltage across 510 ohms, and that value will be displayed in this display unit. You can pause the video and you can note down you can copy down this circuit in your observation or record. So let us see the observation table to determine ABCD parameters, that is transmission parameters. ABCD parameters are nothing but transmission parameters. So first of all, open circuiting the port 2 dash, that is I2 equal to 0. 2 dash is open circuited, that is I2 equal to 0. So when I2 equal to 0, so you have to note down V1, V2 and I1. So you have to perform the theoretical calculations, and before doing the experiment you must note down V1, V2, I1, and after doing hardware experiment you must note down V1, V2, I1, and after doing software experiment you must note down V1, V2 and I1, okay, in this tabular column. You can pause this video and copy the table in your observation or notes. Next, short circuiting the port 2 dash. So when you short circuit the port 2 dash, that is V2 equal to 0. So sorry, here bracket is missing. So here short circuiting port 2 dash. So V2 equal to 0, you can determine V1 value, I1 value and I2 value. Theoretically you just write down, do the experiment, theoretically you just find out using the formulas which I will show later on. Using those formulas, theoretically you can determine, okay, or from the circuit you have to do it actually. So from the hardware experiment note down V1, I1, I2, and from software experiment note down V1, I1 and I2. Next, to determine H parameters, short circuit the port 2 dash, V2 equal to 0. Okay. So when you short circuit the port 2 dash, you have to note down V1, I1 and I2. So do the calculation, determine V1, I1, I2 theoretically and note down here. And after doing hardware experiment, note down the values, and after doing software experiment, note down the values. You can pause this video and draw this tabular column in your notes. Okay, next open circuiting the port 1 dash. So that is I1 equal to 0. You can note down. Here also bracket is missing. So open circuiting port 1 dash, that is I1 equal to 0. You can note down V1, V2 and I2 in the tabular column. So do the theoretical calculations and write down this V1, V2 and I2 and do the hardware experiment and note down V1, V2 and I2 from the experiment, and after doing software experiment note down V1, V2 and I2. Pause the video and copy down this the tabular column. Now after determining all these values, you can determine the H parameter values. So H parameters are H11, H12, H21, H22. So theoretically determine the H parameters and note it down. Practically using hardware experiment, determine the values and note it down, and using software after doing software experiment, determine the H parameters and note it down in this tabular column. Pause this video to note down this tabular column in your observation or record. Now to determine ABCD parameters, that is transmission parameters A, B, C and D. Theoretically determine the ABCD parameters and note down in this tabular column. Practical after doing hardware experiment, determine the ABCD parameters and note it down in this tabular column. After doing software experiment, determine ABCD and note down in this tabular column. So the formulas that are required to determine these parameters I have mentioned in the later slides. Okay, so theory, leave at least one page to write the theory. You have to refer to some electrical circuits textbook to write the theory. So I have left an empty slide here because students, if BTech students are watching this video, they must refer to the textbook to write the theory. So I have just mentioned the theory, and later procedure. So procedure for hardware experiment. So connections are made as per the circuit diagram. Apply 30 volts to the given circuit using regulated power supply. Open circuit the port 1 dash, that is I1 equal to 0. Note down the values of V1, I2 and V2 from the ammeters and voltmeters in the tabular column. Next, open circuit the port 2 dash, that is IT equal to 0. Note down the values of V1, I1, V2 from the ammeters and voltmeters in the tabular columns. Just pause this video and copy the procedure in your observation. Okay, so uh, procedure continues. Short circuit the port 2 dash, that is VT equal to 0. Note down the values of V1, I1 and I2 from the ammeters and voltmeters in the tabular column. And using the tabulated values, calculate the ABCD and H parameters for the given two-port network, and just compare it with the theoretical values. Next, let us see the procedure for software experiment. Open the MATLAB software and click on the simulation button, and later click on the blank model. Pick up the blocks from the Simulink library browser and paste it in the blank model, and connect the blocks as per the circuit diagram, and set the input values, means source values, and block parameter values. Then debug and run the circuit. Note down the currents and voltages. Using the tabulated values, calculate the ABCD and H parameters for the two-port network and verify with the theoretical values. Pause the video and just note it down. Just write down the procedure for doing the software experiment. These are the formulas to determine the transmission parameters, that is ABCD parameters. So the equations for determining the ABCD parameters or transmission parameters, equations are V1 equal to A V2 minus B I2. V1 equal to A V2 minus B I2. I1 equal to C V2 minus D I2. And to determine A value, if this whole term becomes 0, that is IT equal to 0. So when IT equal to 0 means when port 2 is open circuited. When port 2 is open circuited, you can determine A value and C value. So A will become V1 by V2 at IT equal to 0, and C is I1 by V2 at IT equal to 0. Similarly, to determine B and D parameters, V2 should be 0. V2 0 means port V2 0 means port 2 should be short circuited. Okay, port 2 should be short circuited. So when port 2 is short circuited, you will get B value. B is equal to what? Minus V1 by I2. D is minus I1 by I2 at V2 equal to 0. So these are the formulas to determine ABCD parameters, that is transmission parameters. You can pause the video and you can note down the formula. Similarly, to determine H parameters, that is hybrid parameters, formula is these are the formulas. The equation for H parameters is V1 equal to H11 I1 plus H12 V2 and I2 equal to H21 I1 plus H22 V2. So the H parameters are H11 is equal to V1 by I1. H11 equal to V1 by I1 at V2 equal to 0. V2 equal to 0 means what? Port 2 is short circuited. Okay. So when port 2 is short circuited, H11 equal to V1 by I1 and H21 equal to I2 by I1. H21 is equal to what? I2 by I1 at V2 equal to 0. Similarly, H12 H22 can be determined at I1 equal to 0. I1 0 means I1 equal to 0, port 1 is open circuited. Okay. Port 1 is open circuited. So when port 1 is open circuited, so you will get H12 equal to V1 by I1. V1 by V2 at I1 equal to 0 and H22 is I2 by V2 at I1 equal to 0. So H12 is V1 by V2 at I1 equal to 0. H22 is I2 by V2 at I1 equal to 0. So these are the formulas to determine H parameters. You can pause the video and note down this. And using these formulas, you can perform the calculations. Theoretical calculations, you must take the circuit and you must apply Kirchhoff's laws to determine the V1, V2, I1, I2 values. Okay, and later using the formulas which are shown in the earlier slides, you have to determine the parameters and you have to tabulate it. So for doing the calculations, you can leave at least 2 pages to 3 pages. Next, precautions. Initially keep the regulated power supply output voltage knob in 0 volt position. Avoid loose connections and avoid short circuit of RPS output terminals. You can pause the video and you can note down the precautions. And at last, result is for the given T network, ABCD parameters and hybrid parameters were determined for both the hardware circuit as well as using MATLAB software. So using hardware circuit and using MATLAB software, ABCD and H parameters are determined. That is the result. So if you are able to follow, you just click on the like button so that this video can reach to many people. And if you have any comments, if you are unable to follow, or if you have any comments, or if you want me to make any other video, Any suggestions if you want to give, you can mention it in the comment box. So thank you for watching the video.